Hello. Today we're going to talk about the binomial distribution. The binomial distribution occurs when you conduct an experiment over and over again, and the probability of success is fixed. So imagine that you're going to conduct an experiment, make an observation, and there's only two possible outcomes. There's success and failure. And the probability of success is the same each time you conduct the experiment. The binomial distribution then would count the number of successes that you have in a fixed number of trials. So the simplest example is flipping a coin. Imagine that you're going to flip a coin and heads will be a success and tails will be a failure. Then when you flip the coin, there's always a 50% chance of getting heads no matter what happens. So imagine you're going to flip the coin 3 times. The binomial distribution will tell you the probability of getting heads 0 times, 1 time, 2 times, or 3 times. So that's what the distribution does. It tells you the probability of each possible amount of successes in trials. 2 important things about the binomial distribution. There's only 2 possible outcomes. There's success and failure. And you got to just be very specific about what success and failure are. And the other thing is that the probability of success is fixed. So imagine flipping a coin, it's always a 50% chance of success. Or if you're shooting free throws, however good you are at free throws, you always have the same chance of success on each individual free throw. This is in contrast to, for example, say you're trying to chop down a tree with an axe. The first time you hit the tree, you probably have a 1% chance of successfully knocking it down. But by the 10th or 20th time you hit the tree, you probably have like a 99% chance of knocking it down. So you need to make sure that the probability of success stays the same. And this occurs in a lot of situations, which we'll talk about some. Okay, just to review, there are how many outcomes? 2. There are 2 possible outcomes. We call them success and failure, but we could call them outcome A and outcome B. And what is the other important characteristic? That's right, the probability of success has to stay the same as you have more trials. Okay, so the binomial distribution looks like this. Here's the formula right here. And no need to write down and memorize the formula or panic, but it's worthwhile to look at the formula. So we have this part that right here, which is the probability of success is a P, and the number of successes you're interested in is S. Then this piece of the formula right here tells you the probability of getting S successes. Now, if the probability of success is P, then the probability of failure is 1 minus P, and the number of failures that you want to get is N, which is the total number of trials, minus S. So basically, this is the probability of getting S successes and all the rest failures. Now, that first part there just says the way that these can be, the number of different ways that you can organize the successes and failures. For example, if I'm going to flip a coin and heads is success and I want 2 successes, and I'm going to flip the coin 3 times, then there's 3 ways I can organize that. I can get heads, heads, tails. I can get heads, tails, heads, or I can get tails, heads, heads. So that's what that first part does. You don't really have to memorize this formula because it's already in Excel, but you do have to remember the Excel formula for getting it. And I'll show you that right now. So the formula is binom.dist. Several years ago, almost a decade now, Microsoft standardized all of their probability functions, and they use the .dist. So if you forget, so there are a bunch of old functions in there that don't have the dot in them. So there's actually one called binom.dist with no dot, and it works pretty much the same. However, they had different ways of running each of their different probability distribution functions, and so that when they standardize them, they all end with .dist. So we're going to try to get in the habit of using the .dist because that's the way they all work now. If you ever get a weird result, it might be because you left out the dot and you're using just binom.dist without the dot, which won't matter for this, but it will matter for some of the other distributions that are in Excel. Okay, so it's binom.dist, And the first thing is the number S, which is the number of successes. So if we're flipping a coin 3 times and we're interested in the probability of getting 2 successes, you would put the number 2 in there. The second thing is the number of trials. So if we're flipping a coin 3 times, we're interested in 2 successes, you would put 3 for the number of trials. And then the third thing is the probability of success. So again, if we're flipping the coin, the probability of success is 50%. The last thing is the question of cumulative. Are we interested in the cumulative distribution function or the probability distribution function? In general, we're going to be interested in the cumulative distribution function. So if we say false there, then that'll give us the probability distribution function. So for the numbers 2, 3, and 0.5, it'll tell us what the probability of getting exactly 2 on 3 flips of a coin is. If we put true there, then it gives us the cumulative function, which will tell us the probability of getting 2 or less heads on 3 flips of a coin. So in general, we're going to want to use true there, because in general, we're going to be interested in a range. And so that function will tell us the probability of getting the number, whatever number S is, or less. And this is a discrete distribution. So what does that mean for us? That's right, it means that there's only specific outcomes that can occur. So for example, if we're doing 3 trials, what are the possible numbers of successes we can have? We can have 0, 1, 2, or 3, okay? But we can't have 0.5 or 97 or 2.86. We can only have 0, 1, 2, or 3. So it's very important that we do what? It's very important that we write down the actual outcomes that we want. Otherwise, it gets very confusing, right? So it's about like slicing bread. You want to make sure which slices you want in and which slices you want out. Well, you're going to see some examples with that later, but just keep that in mind. Okay, so let's do one. Imagine that you have an airplane. Ow. Anyway, your airplane has 4 engines on it, and the airplane can fly with just 2 engines. But if it has fewer than 2 engines, it's going to fall out of the sky. Okay? Now, just for fun, imagine that the probability of an engine failing or an engine breaking is 20%. And now the question is, what is the probability that the plane falls out of the sky? Okay, so the first step, we're going to want to write down what we mean by the word success. So in the formula, we're going to call things successes and failures. In this case, a success is the probability of an engine breaking, or a success is an engine breaking. So this is why it's important to keep track of what a success and a failure is. So we're probably thinking of ourselves more like gremlins than like passengers. So a success is an engine braking. So step 1, write down what success is. Step 2, because it's a discrete distribution, we want to write down what it is that we want. Okay? So the question asks, what's the probability of the plane falling out of the sky? So how many engines have to fail for the plane to fall out of the sky? Okay, 3 or 4 engines. So if 3 engines fail, you fall out of the sky. If 4 engines fail, you fall out of the sky. So we write down the numbers we're actually interested in, 3 and 4. Okay, so the probability of success, 20%. The probability, the numbers we want are 3 and 4, but we can't calculate that. So the third step is to write down what we can calculate. We can calculate the probability of 0, 1, or 2 engines failing. Okay? So remember, the CDF calculates the probability of some number or less. So this would be the probability that 2 or less engines fail, and then we have to subtract that number from 1, right? So the probability of 3 or 4 engines failing is 1 minus the probability of 0, 1, or 2 engines failing. The formula would be 1 minus binom.dist, 2, because it's 2 or more engines failing that we're interested in, the number of successes, comma 4, 4 is the number of trials, because we have 4 engines, comma 0.02, because there's a 20% chance of failure, comma true, because we want the cumulative distribution. So that's going to tell us 1 minus the probability of 2 or less engines failing which is the probability of 3 or 4 engines failing. And if you do that, you should get 0.0272. Okay? So the probability of the probability that you fall out of the sky is, 2%, 2.7%. Okay? In Blackboard, you'll always need to put it in decimal form because it doesn't recognize percents. So there's 3 steps. First, write down what we mean by success. Second, write down the actual outcomes you want, the numbers 3 and 4. And the third step is write down what you can calculate, which may not be the same as what you actually want, in which case you might need to subtract from 1 or subtract from some other number. All right, I'm going to let you try one now. Imagine that you have a 2-engine plane, and that engine can fly with only 1 engine working. And again, the probability of an engine breaking is 20%. What's the probability that that airplane falls out of the sky? So 2 engines, 20% chance of them falling out of the sky, and you'll fall out of the sky. You can stay in the air if you have 1 engine, so you'll fall out of the sky if you have 0 engines. Calculate that. Okay, step 1, write down what a success is. A success in this case is the engine failing, and the probability of success is 20%. What numbers do we want? Well, the number that we want is 2. So remember, we're trying to get 2 engines to break because that's what makes the plane fall out of the sky, and that's the thing that we're looking for. So we want 2. So the second step, write down 2, probability of 2. But we can't calculate that. We can calculate the probability of 0 or 1 engines breaking. So we say 1 minus the probability of 0 or 1 engines breaking, which is 1 minus binom.dist of 1 success, comma, 2 tries, comma, 0.2 chance of success, and true, because we want the cumulative distribution function, so we want 1 or less. And that gives us 0.04, or 4%. Okay, so you say, well, this was kind of a creepy example of the airplanes falling out of the sky. But this is exactly why, if you've ever gone on an airplane that flies across the ocean, you're always going to be flying in an airplane with 4 engines. Because the FFA made this same calculation, and they said the probability of engines breaking are such that if you fly in a 2-engine plane, it's unacceptably risky. Now, these calculations were made many years ago when plane engines were less reliable than they are now, and some airlines are trying to convince the FAA to change the rules so that they can fly 2-engine planes across the ocean. But the point is, the binomial distribution is really a real thing that's affecting your life and either saving lives and or making transoceanic flights more expensive and more inconvenient. But it is affecting your life. All right, let's work through a couple of more. We're just going to work through problems for the rest of the video, so let's do it. All right, so here's a question. Imagine that you're doing some online dating, or you're trying to do online dating, and there's a 10% chance that your right swipes are reciprocated. So I've never actually done this, but my understanding is if you're on Tinder, you see somebody and you can swipe right or swipe left. If you swipe right, that means that they're allowed to also swipe right, and both people swipe right, then you get each other's contact information. If you swipe left, that person's not allowed to contact you. Okay, so if you swipe right, there's a 10% chance that the person that you're swiping right on will also swipe right, and hence you will be able to talk to them. Okay, if you swipe right on 10 people, then what's the probability that you will get 4 or less contacts? Okay, so remember, you swipe right, there's a 10% chance that the other person also swipes right, and that is a contact. What's the probability that you will get 4 or less contacts if there's a 10% chance and you do it 10 times? Okay, so step 1, write down what a success is, and that is your swipe being reciprocated. Step 2, write down what it is that you want, and we want 4 or less. So we want 0, don't forget it's always possible you get 0. 0, 1, 2, 3, and 4. Okay? As it turns out, we can calculate that. So the third step is just to write that down again. So it would be binom.dist, parentheses, number of successes is 4 or less, comma, 10 is the number of trials, comma, 0.1 is the number of, is the probability of success, and true, because we want the cumulative distribution function. And if we do that, the answer is 0.99836506. So there's like a 99.9 almost percent, 99.8% chance that you will get 4 or less contacts. Okay, so let's do the same question again. What's the probability that you get less than 3? So again, the parameters are, there's a 10% chance that if you swipe, somebody else swipes. You swipe 10 times, and you want to know the probability that you get less than 3. Okay, so in this case, once again, step 1, we write down what a success is. A success is that your swipe is reciprocated. We write down what we want, and in this case, what we want is 0, 1, or 2, right? Because the question asks for less than 3. 3 is not less than 3. 3 is exactly equal to 3. So always be careful what number you're actually looking at, how you slice your bread. If you want less than 3 and you get 3, that's not appropriate. So what we want is 0, 1, or 2. Okay? What can we calculate? Well, we can calculate 0, 1, or 2. So the probability of getting less than 3 is the CDF at 2, which would be, this is binom.dist 2, because we want 0, 1, or 2, so 2 or less, which is less than 3. 10 for the number of trials, 0.01 for the probability of success, and true again because we want the cumulative distribution function. Okay, so always keep in mind what is 3 or less, what is less than 3, right? 3 or less includes 3, less than 3 does not. And so we got to be careful that we start at 2 for that one. But if you wrote it down, you're good to go. If you wrote it down and you're paying attention. So the answer was 0.9298. So 93% chance that you will get less than 3. Okay. So same question again, but this is probably really the one that you want, at least one. So in other words, you're swiping and you're like, oh, hey, I've swiped 10 times. What's the probability that at least one person will swipe on me, and we can, chat or do whatever. Like I said, I've never done this, so I'm not exactly sure what we do next, but I guess we send each other texts or instant messages or whatever. Anyway, what's the probability that you get at least one? Okay, step 1, write down what a success is. A success is that somebody else swipes. And write down what you want. You want at least one. So what we want is 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. We'll take any number, basically, except for 0. We can't calculate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but we can calculate 0. So the third step, write down what we can calculate, which is 0. So we have 1 minus binom.dist of 0, because that's the number of successes we want, 0 or less, which is the same as just 0, comma 10, comma 0.1, comma true. In this case, if you put false, you will get the same thing, because 0 or less and 0 have the same probability, because there's only one outcome there that's being counted, and that's 0. If we do that, we get 0.6513 blah, 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 blah. So there's about a 65% chance that you get at least one if you swipe 10 times. So when you're doing your online dating, swipe 10 times, 65% chance that you'll get a response. Of course, I guess you can just go back and swipe some more. Okay, so does that make sense? I don't know why I'm asking this, because you can't answer, but whatever. Okay, let's move on. Let's work another one. Okay. This one is going to be a little bit more interesting. because now we're going to solve for something other than the probability. Okay, so it's the same question, but now we ask how many you would need to swipe to get a 90% chance of at least one. So here's a situation. I'm going to go, and I know that there's a 10% chance if I swipe, somebody else will also swipe. And I want a 90% chance of success. So the question is, how many do I need to swipe to make my chance of success 90%? So the formula for this is going to be slightly different. It's going to be, we already calculated the formula for getting one or more, which is 1 minus Banome dist 0, comma, in this case, we'll talk about what this is, but n is the number of trials, and that's what we're trying to figure out is the correct number of trials, comma, 0.01, comma, true. It's always going to be the same formula, so all we have to do is change that number 10 to some other number. Now, we know that 10 gives us a 65% chance of success, and we know we want higher, so you can use the solver, you can just start typing in numbers. I just started typing in numbers, so I tried 20. If you type in 20, that gives you an 87% chance of getting at least one. So I said, it's got to be higher than 20. So I typed in 30. 30 gives you a 95% chance, 95, 7, 6 something. So I said, okay, 30 is too high. So let's try 25. 25 gives you a 92.8% chance. That's still too high, so let's try 22. 22 gives you a 90.90152291, which is still higher than 90. So I typed in 21. 21 gives you 0.8905. So 21 is too low. So I got to go with 22. So 22 is going to give me at least a 90% chance of getting at least one person to swipe on me. So if I've gone to you're out of town, you're in a new city, you want to chat with somebody in that new city, you go on Tinder or Grindr or whichever you prefer, and you start swiping, and you say, how many of these people should I swipe on so that there's at least a 90% chance that I'll talk to one person in this new city? You need to swipe on 22 people. Okay. Let's move on and do a similar question. All right. Imagine that you need to hire to fill 3 positions. So you have 3 positions you need to fill, and so that's the number of successes is 3. And 70% of the people you interview are qualified. How many people do you need to interview to have a 90% chance of getting at least 3 qualified people? At least 3, okay? Because you want to hire 3 people. And so your hiring committee says, well, how many people should we invite for interviews? You have a big stack of applications. You need to invite some number of people for interviews. You don't want to invite just 3 because one of them might not be qualified, but you don't want to invite 300 because you only need to find 3, okay? So we want a 90% chance of finding at least 3. All right, I'm going to let you struggle with that for a minute. And what you're going to have to do is, once again, change the number in of trials that you have and keep the number of successes and so the number of successes and the probability of success the same. So first, just pick any random number you want, figure out what the formula would be for that, and then just keep changing that number. So I'm going to let you work on that for a minute, see if you can figure it out. Okay. So the first thing is, I want to make a guess here, and I'm just going to randomly guess 5 to start with, okay? So I'm going to say, if I have 5 trials and I want 3 or more successes, what's the probability? So first thing, write down what a success is. Success is having a qualified applicant come to the interview. That's a success. What do I want? Well, I want 3 or more successes. So if I have 5 trials, 3 or more successes is 3, 4, and 5. Okay? I can't calculate that, so step 3 is write down what I can calculate. I can calculate 0, 1, or 2 successes. So my chance of getting 3, 4, 5 successes is 1 minus my chance of getting 0, 1, or 2 successes. And the formula for that is, of course, 1 minus Banome.dist, 2, because I want 2 or fewer successes, comma 5, because I have 5 trials, comma 0.07 because the probability of success is 0.7, and true because I want cumulative. And if I do that, I get 0.83692. So 5 is not enough. If I just interview 5 people, I have an 83% chance of getting 3 qualified people, 3 or more qualified people. So now I'm just going to take that same formula and I'm just going to change the number 5 to a 6, because notice the thing that I don't want is 0, 1, or 2, and that stays the same no matter how many trials I have. So if I do that, it's 1 minus binome.dist, 2 successes or fewer, comma 6, comma 0.7, comma true, and that gives me 92953, 0.92953. So that gives me a 92% chance of success. So I should come back and tell the hiring committee we need to invite 6 people in for interviews, because that'll give us a 90% chance of getting 3 or more qualified ones. Now we might get 4 qualified ones, we might get 5 qualified ones, we might get 6 qualified ones, but all we really need is 3. So we would want to invite 6 people. Make sense? I keep asking that. I hope you're answering. All right, I'm going to do one more, and in this time we're going to have to change the probability of success. Okay? So imagine that imagine that 70% of your drill bits break and need to be replaced. Say you're drilling oil wells, and by 1,000 feet, 70% of your drill bits break and need to be replaced. I don't know what the actual rate of drill bit breakage is, but drill bits break, which is hard to say. So 70% of your drill bits break and need to be replaced. So a guy comes out, or a woman, or some non-binary person, anyway, comes out and says, hey, I've got this new drill bit, and this new drill bit is better than your old drill bit. And so you buy 10 of them, and only 3 of them break. Are they really better? So before we work on this, just think about what the probability question is here. So the question is, how likely, so if a drill bit is 70% likely to break, what's the probability of having 3 out of 10 of them break? We want to compare that. Actually, we would say, well, what's the probability of having 3 or fewer break? We were expecting 7 to break because they're 70% likely to break. If 6 broke or 8 broke, we would probably say, that's not too weird. But if only 3 of them broke, now we need to say, hey, what's the probability of being that good, of being 3? But we would also probably want to include the probability of 2, 0, and 1. So what's the probability of having an outcome that extreme or more extreme, at least that extreme, given that there's a 70% chance of them breaking? What we would do here, we say, what's the probability of 3 or less successes in 10 trials with a 70% chance of success? So you calculate that. Okay, step 1, what's a success? It's a drill bit breaking. So I guess we're like, do oil fields have gremlins? Whatever. It's an oil field breaking. It's a drill breaking. So success, drill bit breaking. What number do we want? Well, we want 3 or less, so we want 0, 1, 2, or 3. Okay, and we can calculate that. So what we want to calculate is 0, 1, 2, or 3. So that would be the binome.dist of 3 successes or fewer out of 10 trials with a 70% chance of success, and we want true because we want the cumulative. So we're calculating the probability of doing at least that well or better, and it turns out to be 0.01059. So there's a roughly, if you had drill bits that broke 70% of the time and you had 10 of them, there's a 1% chance that out of 10 of them, 3 or fewer would break. So this person that's claimed to have better drill bits probably actually has better drill bits. Let's review. Binomial distributions has how many outcomes? 2. We call them success and failure, but that doesn't always match up with our conceptualization of what a successful thing is. Binomial distribution probability of success is what? That's right, it's fixed no matter how many times you perform the operation. Okay? So let's go through the steps in solving a binomial question. Step 1 is write down what a success is. Step 2, write down what outcomes you want out of the possible outcomes. Step 3, write down what outcome you can actually solve, because the cumulative distribution function says the probability of this number or less. And sometimes that's not the same number that's in the question, and we need to adjust to see what we can solve. Goodbye.